This is Dr. Carroll, and today's video is about object-oriented programming. Okay, so that's the topic. Having said that, let's back up a little bit and talk about what's not object-oriented programming. So back in the caveman days when started programming, what was typically done was procedural programming. Okay, or abbreviated PP. Procedural programming is often found in languages like C, Fortran, Pascal, etc. And what the programmer focuses on are the verbs in a problem specification. It focuses on the verbs, the action words in a problem specification. And so they'll break down the problem into tasks, into subproblems. And subproblems then get translated into functions or subroutines, and then they'll group these subroutines together until they have a program. And then what often happens is the data is passed around as arguments. And so you'll have a struct or some variables that get passed from here to there, or even worse, have global variables that everything acts on. There is a time and a place for it. For example, if you want to circumvent the overhead of other approaches, procedural programming can be faster, and that can have its advantages. Procedural programming can use classes, but generally focuses on the steps. So now let's talk about object-oriented programming. I can't. OOP, okay? And so as the name suggests, it focuses on objects. And in the problem specification, it focuses on the nouns. And so you're reading a problem specification, it's going to say, well, what are the key players here? What objects are we talking about? And let's create an object for each one of those. Well, so what is an object? An object is an abstract concept. The best analogy that I've found is a blueprint. Okay, so you have an object in code. It's like a blueprint. You have the specifications of how it's going to look. Often when we think of blueprints, we think of homes. So if you think a builder puts in a lot of time and money to develop the perfect blueprint, what they do is they use that, at least builders of subdivisions, for example, they'll often use a couple of blueprints, and they'll make several homes based on that blueprint. Now, the homes don't look all the same. One might have blue paint, one might have yellow. The type of roofing, for example, could be different. Could be sheet metal, which is more recyclable, by the way. And so the specifications in the blueprint suggest it's a template, it's a framework. And then, as to use a programming term, we would instantiate the blueprint. We would make an object, and then would fill in the variables. What are the values? What is the paint color? What is the roof type? Those things can vary, but they still fit within the blueprint. So if you're trying to think, well, what is an object? How does it work? You can think of blueprint. That's in your .h file, that's the specification. And then when you instantiate an object, then you're taking the blueprint, and I like to think of it as being like stamped down, and then out pops a house. Now they take a little bit longer than that, a lot longer, but that's a visual for you. Then once you've designed and initiated an object, then what object-oriented programming is, you modify and work with the data. And you do this by sending a message to the object to work on itself, to modify itself, or do something like that. you can have too many objects, and there's overhead incurred with objects, so there's a moderation in all things. So let's talk about an example that helps highlight the difference. So if you wanted a program to keep track of time, meaning hours, minutes, seconds. If you had a procedural programming approach, what would that be like? You'd probably have something like a time struct that you just share and pass around to different routines like display time. And it would take a struct and, for example, you might pass it to increment time and or set time. And you'd pass the structure along and you'd keep track of the struct. Okay, now that we've talked about procedure programming, let's talk about object-oriented programming. What would that look like? One approach would be you would create a watch object, for example. And then, thank you. And then you'd make requests of that object. For example, you'd call watch display time. And the scope resolution operator and the class name here are explicitly given to show that you're calling the watch's display time. And so it's going to work on its private data members. Or you could have it be increment and have it increment the time, etc. Another example would be a chess program. Any chess champions out there? So a procedural programming approach would and it just controls every piece, it knows where every piece is, it knows the board, and it has a control of that. The object-oriented approach could be to make a chessboard, and the chessboard would make it, chessboard knows it needs to have the 32 pieces, and it would call for each of those to be made. And so if you said, hey, chessboard, refresh, redraw yourself, then it would do that. It'd say, hey, I need the chess piece in the third column, second row to redraw itself. And then it would call on that object, say a knight, and it would redraw itself that way. See the difference? So that's object-oriented programming. I hope you enjoyed it.